की बात नहीं होती कि अपने आउटपुट करेगा, इनपुट करती है ना, इनपुट है लेकिन नहीं कर दो। वैसे लोगों को पर्सनली छोड़ के बात नहीं है, उनको किया उन्होंने गलत को बोल दिया, नहीं है कोई नहीं है, क्यों? क्योंकि बच्चा
Good afternoon, all of you. We have been trying since last 10 minutes to contact the speaker, but then there are some issues, I think. So we are not able to contact the speaker till now. So what we'll do is we'll call it off today and we'll tell him to share the slides with us. And no questions will be asked from this session. Okay. So we'll stop today.
Okay, shall we leave the meeting, sir, or
Yeah,
what else?
you can leave the meeting because we are not able to contact yet. So I think there is no other point. It's almost 3 o'clock now.
Yeah, yeah.
So we'll
Since
call it.
he's from UK and maybe there may be some difference of
Yeah, we have been
timing.
trying through WhatsApp and other email, etc., but then it's not responding. So there is some issue maybe with this WhatsApp.
Hello, sir. Hello, Mr. Shubal Banerjee. Hello, sir.
Yeah, yes,
May I
please.
say something?
Yeah, please.
Yesterday, the feedback form which was being given, the link it was showing a suspicious link, so I could not like click that one. Whenever I was clicking, it was showing that the link is suspicious. I don't know
No,
what is the reason.
the link was made in our department. There is no suspicious page. You can safely give the feedback in that form.
Okay, thank you, sir.
Okay.
So, sir, today we can leave. Then tomorrow the meeting will resume at 9:30, sir.
Yeah, tomorrow 9:30 same time. Okay,
Okay.
in the morning.
Then today
Yeah.
we are
Okay.
leaving, sir.
Yeah, you can leave today. Okay, we'll call it off today.
Okay.
Okay.
Thank you so much, sir.
Okay.
Thank you so much, sir. Yeah, bye.
Okay, welcome back.
Take care.
Thank you so much, sir.
Thank you so much.
Dr. Vijay. Hello, Dr. Vijay.
I have
Sir,
technology
are you,
kills sometimes. So I was trying to connect, but so
yes, sir, there were some issues.
can you tell me at which it was 45th or which slide?
I'm sorry, sir. Can you repeat that? Your voice is breaking.
Oh, so I'm asking like on which slide I was. It was 45th or something. I think where we lost, right?
Sir, it was like just you started. Couple of minutes later, it got disconnected. Around 2:30, it got disconnected, sir.
Okay.
Yeah.
Okay. So I think I can just start from.
From yeah, sir. From once that materials you were talking about, and after that.
Okay, I can just like I have.
Yes, sir. Yes.
Let me. Can you see my screen again?
Not yet, sir.
So are you able to see the screen?
No, sir.
Just. Now I think it will take a couple of minutes.
Okay. Yeah. Now we are able to see, sir.
Okay. So just in case if it lost again, I'm sorry, but it's
Sir, immediately I'll email you. Please look into the email.
case. So my apologies again for. Yes, okay, thank you. So it takes some time to sort it out. So
Yeah.
I think we can continue. So the question arises like why we really want to use cellulosic nanomaterials. So cellulosic nanomaterials, they offer a number of advantages to the traditional synthetic counterparts, and they can offer a number of properties, environmental friendliness. One of the concern, as I said earlier, there has been on the use of the terminology. So which terminology should be used? Either use cellulosic nanoparticle, nanocellulose, or nanofibrated cellulose, or cellulose nanocrystal. So to give it a more generic view, together with Professor Janet and Elizabeth, we have come with 2 new books on cellulosic nanoparticles, where we have used a terminology called cellulose nanoparticle, so that if you are not targeting a specific application, then you can more of the word like cellulose nanoparticles. And we have been using cellulose based starting from micro to nano scale for packaging application, wind turbine blades, another sustainable product. One of the key area of thrust has been on wind turbine blades. 30 years down the line, there will be a huge problem of recycling of traditional wind turbine blade because of glass fiber based material. We are trying to replace the traditional glass fiber with cellulosic nanofiber, although we cannot replace that 100%, but we are trying to hybridize them with cellulosic nanocrystal, or you can say cellulose nanofibers. And synthesis has always been a big issue because we need to go through different chemical or mechanical treatment, and the properties of cellulosic nanofiber significantly varies depending upon which method you have used for their synthesis. And why so important? Easily procured continuously from biorenewable sources. As Professor Paul from Kamar University has said that we can really save the world through our forest because our forests act as living factories for continuous generation of these cellulosic nanomaterials. Among different types of cellulose, bacterial cellulose is really very important because if we have used cellulosic nanomaterials in biomedical application material, and sometimes if you want to get a 100% transparent material, bacterial cellulose is not a bad choice. Different types of techniques can be used to prepare cellulose nanomaterial, whether you are synthesizing cellulose nanocrystal or cellulose nanofiber. It depends. If you are using mechanical defibrillation method, you will generally get cellulose nanofiber, or if you are using traditional acid hydrolysis, you can get, but again, it depends upon how effectively you synthesized. In this image, you can see we have been able to find that cellulose nanofiber and very cellulose nanocrystal can get a crystal clear solution. And if you have to differentiate between cellulose nanofiber and cellulose nanocrystal to a non-scientific person, the perfect example is where you can relate cellulose nanofiber, this one, cellulose nanocrystal to a price. This is a very common between these two. We are also exploring the use of these cellulose nanomaterials for healing applications. So most of the engineering materials during their life cycle undergo some sort of damage, and this damage is really very critical when it is either related to aerospace or either it is related to biomedical, because suppose we are flying, don't have a chance if there is some sort of critical issues, you cannot bear in air. So in this case, self-healing materials are getting greater attraction, although there are lots of concern, one among being their high cost. Traditionally, Grubbs catalyst and dicyclopentadiene-based monomers have been used for self-healing applications, but their cost is really very high. Some soft materials can be easily synthesized, but they cannot be really used for structural applications. So we have been exploring the use of cellulose-based material in which both the core and cell are from biorenewable sources, and we have been able to get good properties. We are not up to there, but we have made significant progress where prepared from all biorenewable sources have shown a very good preliminary results. And since you cannot really get always excellent properties with the pristine cellulose, certain surface engineering or treatment techniques are used, and these techniques also consume significant amount of energy. So whenever we choose any technique, we have to be careful on the choice of our solvent or the application. And even when we choose a particular, say, hydrolysis technique or chemicals, we must control it in a very precise way, because if we use in excess amount, we can really change its dimension or properties. And one of the example of emerging nanomaterial is sugar beet. Sugar beet is similar to sugarcane in India, and in UK, especially in Scottish part, farmers are working very closely with the academicians politician and industry to transform these waste into high value nanomaterials where they can be empowered through the use of each and every part of its component, and the dimension of different nanomaterials varies depending upon the precursors used. Researchers, especially physicists, they have also been looking into the use of cellulosic nanocrystal for liquid crystal applications. Have some very good properties. Again, you need to carry out appropriate modification for the purposes. It can be through ATRP or TEMPO. ATRP is having used because it needs sophisticated chemicals that may not be good from industrial perspective. Silylation and esterification are the one of the most commonly or frequently used and desired from industries. Challenges with cellulose nanofibers, as I said, is entanglement. It generally forms more of like gel-like material. You may not find it so that is one another problem for cellulose nanofibers. And how to maintain the structure of cellulose nanocrystals? You have to be careful again with the choice of the component precursor, whether it is from wood or it is from nano plants, or you can say super beetroot. Again, your solvent also plays a key role. Here you can see when we use water to dry, you can see there are more of like different stuff, and then if you see DMA, here is more of like aggregated structure, and media affects modification efficiency. In most of the cellulosic material research, your medium is really very important. Although cellulose-based nanomaterials offer a number of advantages and it is being portrayed as materials for the future, it still has a lot of issues because it uses higher amount of water. And if we look from green chemistry perspective, this is not really desired. So field is open for research how we can eliminate the use of traditional harsh chemicals so that you don't need to use excess water for their purification. And modification again is very important. There are different techniques that can be used for their modification. We have summarized most of the technique. You can say anything but not everything in this book, and if you want to go into more detail, you can refer to this book for surface engineering of cellulosic materials. Here are some of the examples where researchers have used acrylamide brushes to graft on CNC to make it more like smart materials. Carboxymethylation is another technique that can also be used for the modification of cellulose nanofiber combined with hydrogenation. Acetylation, as I said, although very simple technique, but very impactful because you can use it at large scale. And here you can see with the amount of acetyl, you can get more of like high value cellulosic nanomaterial, quite transparent. And the applications of cellulosic nanomaterials are huge. You name it and you will find it. And some of the possible application we are looking in is green composites, rheology modifier, and we are also carrying out significant modification on cellulosic nanoparticles for use in both biomedical as well as defense applications. One another area we are are looking into 4D printing of materials, how we can combine nanofibrous material with vegetable that can be used for medical applications. And here is some of the example of 3D printing, where we have been able to develop different types of products. Another area we have been looking into how we can use electrospinning to develop new materials. As you can see, we have been using different types of precursor, again synthesized from bio-based resources. Here polymer matrix and the graphene and they have been synthesized through sustainable foods, and they have shown really very good properties, and we are currently using them for biomedical application, and we have been able to produce them at large scale at our industrial partners facilities. We also studied their thermal properties. Although graphene did not show significant enhancement in thermal properties, but nanofibrillated cellulose show significant improvement, and it might be due to better interaction between these two different materials. Here we also use another analytical techniques to verify the interaction between the PBS matrix as well as the nanomaterials. And we have been also exploring the use of another bio-based material, say isolate MFC graphite for development of different composites. And we have answered one of the fundamental questions that still remain unanswered. Traditionally, it is accepted that nanomaterials enhances the mechanical performance, but this is not always the case. Through our recently project, we have proved that it's not really your nanoscale. There are several other parameters that also controls your mechanical performance. As you can see from here, we have got higher mechanical properties for MCC compared to nanofibrillated cellulose. Also, we have compared the two traditional techniques known as master batch process used by industry and then solvent casting process generally used at lab scale in most part of the world. And we have found it really quite interesting that master batch process shows significantly better properties. Here are some of the images of the materials prepared through the processes. We used thermal analysis technique to categorize what we have done. Here you can see there are some changes between the master batch as well as solvent based processing. What is most important to note is in case solvent based casting, the materials generally evaporates because you have the solvent, while in case of master batch, the sustainability, or you can say thermal stability, is slightly higher. What was most important to us is to see for how long your prepared nanocomposite film survives. And as you can see, initially there are no spots. Here we can see different stars slowly building up, and then it gets almost degraded after few weeks. So this material has high potential to be used in automotive or packaging application. Then we also study the mechanical properties. Obviously, the master batch shows better properties. Then we have been asking the use of traditional antimicrobial material, say curcumin. We have combined it with cellulose to come up with new dressing systems where we can replace that material, because wound healing is a big problem, especially in case of burning. Also, we have been exploring the use of another nanofibers that combined with cellulose can give smart structure. Here, this work was funded by Protect to develop new smart aerospace composite, and we have been able to get good preliminary results. Another area we are exploring is to use of hydrogel nanocomposite for water treatment, especially in African sub-hub. There are not many people who have access to good quality water, although there are promising techniques these days, but they are not really quite economic. So we have been exploring the use of different type of bio-based membrane and hydrogel to address these issues, and now we are also combining self-healing characteristic of hydrogel so that you can use these materials multiple times, especially for water treatment application. Some work has been reported on use of aerogel. They are really very promising material, and recently we have reported our findings on use of hemp, that is generally known as cannabis plant in India and another part as well, but UK and in countries, farmers are now being given to grow this crop because hemp has huge medicinal value, and together with local industries, we have been using hemp-based straw for the development of new aerogels as well as insulating material for packaging and other applications. As you can see, thermal properties, we did a lot of analysis. Thermal properties were as good as traditional wood-based materials. These are some of the images for these materials. Also, we studied the specific strength or elastic model. They were quite good for both materials. Thermal conductivity was dependent upon more of porosity, and this work was funded by industry as well as has received significant media traction in the UK because we were the first to use this material starting from biomedical application, then use the leftover to develop new insulating materials that can replace traditional synthetic polyurethane or polystyrene based foam because it is more than nearly 20 billion industry, and now several industries are coming forward to further commercialize our product, and these nanofabricated cellulose can also be converted into transparent film. I won't go into more detail, but yeah, this application in packaging is really very important because cellulose nanofiber act as a good oxygen barrier, and this application is now getting attraction both from defense people as well as another because it can really address the food problem. During the start of this pandemic, there were food related issues in supermarkets in UK and another part of the world except India, where people rely most on the packaging material, and since the materials could not survive long, it has now become pertinent to look for more larger than life product that can be saved for a long time and also eatable and degradable. For this significant amount of treatments can be used. Sometimes wax is being currently explored. Then we are also exploring the use of cellulose nanomaterials with hyaluronic acid for cartilage application. Some work has already been done, and what we are doing is we are trying to synthesize new cellulose nanomaterials with limited content of traditional chemicals and exploring it with certain bio-based lubricants, and the results have been very promising. And also we are exploring the use of sustainable polymer matrices. I won't go into more detail, just to summarize some of the commercial application of nanocellulose. Currently in Japan, there are few companies who are developing diapers from different cellulosic nanomaterials, and viscosity control in Canada because they are the home to one of the largest forests in the world. Then especially for dispersing and 3D printing, we recently finished our project sponsored by Malaysia on use of these different types of bio-based material as a more of like viscosity enhancer. And as you can see, although these materials, you will find thousands of applications related to cellulose nanomaterials, but there are only limited industries in the world that can meet the need of these different type of products because there are always lots of related issues, especially processing, and then again uniformity in the properties. There are a couple of them in India, but none of them still can meet the needs of the industry. So the field is open for everyone to come up with new procedures or manufacturing processes that can meet the development of all sustainable materials. And we have been also use of cellulosic nanomaterial in additional cellulose amendment, taking it from our earlier published work where we are now with cell for osseointegration application, and we are also marrying of carbon nanotube with cellulose nanocrystal. One of the problem with carbon nanotube is its toxicity issues. So we must try to eliminate those because it really have good mechanical properties, and we are exploring the combination of both. Cellulose nanomaterial, if we have to summarize their properties, they have huge commercial applications. You name it, and you will really find their application in a number of fields. If there are no scientific application, you can see you can use just them as a packaging material. So we really have lots of scope to work in this direction. And if I have to summarize, we must explore the material that we have not explored so far for a net zero emission. We must unlock the potential of seas and ocean and use wisely what we have been using. Nothing new. These have been used by our forefathers. We must need to combine it with advanced technologies, and we are also welcoming submission, especially on sustainable nanomaterial in most of the journals. Currently, we are focusing more on nanotechnology for environmental engineering. So we will welcome submission on the journals, and if somebody is interested in publishing their book, so I am a series editor for 2 books. So research proposal are most welcome. We have also have a series devoted to Gels Horizon, where we are mainly focusing on hydrogel material for biomedical and other applications. Last but not the least, I would like to thank each and everyone who have contributed to this journey. There are many people who have helped so far, since I cannot name them. So thanks to everyone who have helped. And especially thanks to the funding agency who have supported this research. In UK, the work has been supported by EPSRC, Innovate UK, Royal Academy of Engineering, and UK. These both projects were run in partnership with India and then our industrial partners. And I will be happy to answer any question. And thank you again for the precious time and apologies for the technical difficulties.
So the floor is open for discussion. Any questions participants have, please, ask.
Can I ask Saival?
Yes, sure, sure.
Yes. Sir, it was very interesting talk. This is Umasankar Patro from DIIT. I have 2 questions, sir. Yeah, one is this, you told about the cellulose fibers in 3D printing. So I was just curious that this cellulose, whether, I mean, because the melting temperature is very high, so how it is possible for 3D printing? Just the first question.
So we are exploring 2 techniques. If we are going for structural application, like if you remember, we have used polybutyl succinate, and the thermal stability analysis result shows that up to 200 degrees C, these materials are good enough to be used, and obviously you cannot go more than 300 when you are using cellulose nanomaterial for printing. And we have been doing this printing with soybean oil-based polymer, where we incorporated some UV moieties that can accelerate the curing of these polymers. And for traditional biomedical applications, we are using more of like solvent-based approach for 3D printing, where we don't need to worry about the high temperature of these materials.
Thank you. I have one more question. Can I go ahead?
Yes, yes, surely.
Yeah. Can you please light on this the water treatment of hydrogels that you have mentioned? Can you
Yes,
give
so
little more light on
yes,
that?
so hydrogels, they are how you can say most emerging class of material that can absorb at least more than 10,000 amount of their water. But problem is their reuse. Generally, traditional hydrogels you will find tons of papers. You cannot really recycle them multiple times. Their mechanical disintegration just started after you recycle 2 or 3 times. So we are combining these cellulosic nanoparticles. So idea is to use them as a reinforcement. And since they have also large area and we can engineer their surface characteristics, so we are able to get new hydrogel with strong mechanical properties combined with enhanced heavy might line absorptions.
Thank you. Thank you very much.
Any other questions from participants? Sir, I have one question.
Yes.
Conversion of cellulose from cellulose to nitrocellulose is a tough thing, and it takes a lot of time also, being reversible in nature. So will this nanocellulose help in the faster conversion to nitrocellulose?
Yes. So I won't go into more detail. This is something we have been exploring in crane field since. So there are some issues with it, but it's a very promising material. I can say that we are putting significant efforts on these different type of cellulose derivative converted into nitrate derivative, are also exploring its use together with graphene for some sensing material, where we want to check the traces of explosive left over maybe 50 years back or something, how they are impacting the crops and so on. But it's really very promising and challenging. So we cannot come up with a clear conclusion, but I know you have a good idea of this one. So I can say that it's a very promising material.
Yes. Any other questions from any participant? Please feel free to ask.
If Seval,
Yeah.
if no questions, I have actually few more doubts. I
ask.
think. Yeah. So what I understand is, I mean, this nanocellulose you used as a filler material, not as a
Yeah.
like single material. Monolithic are not used. It's a
Yes, yes.
okay.
But
So
you can
I
use
was
it
just
in
curious.
multiple.
Okay. I was just curious that this hydrogels you mentioned, I mean, just now I asked the question. I'm sorry again, I'm bringing that. So this hydrogels, can you recover it
No
again?
problem, no problem.
I mean, can they be used
Yes,
as a filter, or it's simply a adsorption of heavy metal ions?
yes, we can
Because
use
we are
them as a
working similar.
filter. Yes, they can be used as a filter. You just need to transform them into more of like membrane type stuff or thin films, and then they can be used multiple times. But one of the issues we have faced, like I said, that you cannot use them like 10 times, 20 times. So we have been trying to reinforce them with some materials that plays a dual role, enhances mechanical properties as well as act as a absorbent. You cannot again compare with traditional equipment we have in India, but we were trying to sort out something for African continent through our CCRF projects to at least drinkable water.
Yeah, I was just a little like concerned about this mechanical properties as you mentioned,
Yes,
because
yes,
once you apply some pressure, then probably it will just tear
Ye-
up.
Yes, mechanical properties is the concern with hydrogel. So here we need to control the cross-linking and then reinforcement. So right now the biggest question is how you can simultaneously enhance the mechanical properties without compromising the absorption capacity. So in this case, cellulose nanomaterials are quite good because you can use them as more of like filter material as well.
In fact, sir, we are preparing some polyurethane based filters.
Oh, okay.
So if I write you personally, I think, is it okay
Surely,
through
surely.
maybe I will.
So very happy to collaborate, and we can talk, we can have a meeting as well. So anyone interested in collaboration or simple talk, we can always, because science without borders, I believe in science without borders, and
Yeah.
it's always a great privilege to collaborate with our own people. So,
Thank you very much. Thank you very much.
So if there are no other questions, maybe we can thank Professor Vijay Thakur for this wonderful talk, which has lot of applications for futuristic generation, as well as the novel materials that we talked about. So I thank you very much, sir, for giving this wonderful talk, and we will keep on interaction with you. And I request you, sir, if you can send the PPTs without deleting the confidential material for the benefit of our participants.
okay.
Okay.
Thank
you,
you.
sir. Thank you very much. Thanks
Bye.
for
Take
attending.
care. Bye.
Okay. You too. Okay. Thank you. We'll wind up for today.
Okay. Bye.